Welcome to Spaceverse, your portal to cosmic adventures. This is the solution to a problem that once seemed capable of shattering our understanding of the universe. For the past few years, astronomers have been deeply puzzled by a surprising discovery made by the James Webb Space Telescope, an unfamiliar group of ancient galaxies. These galaxies were compact, distinctly red, and astonishingly luminous. So luminous, in fact, that some experts began to question whether our entire understanding of cosmic evolution had been fundamentally flawed. These mysterious objects were quickly dubbed little red dots, and they caused a stir in the astrophysics community. They didn't behave like normal early galaxies. They were compact, distant, and unusually luminous, as if they contained far more stars than our current models of galaxy formation could account for so early in the universe's history. But now, new research may have finally cracked the mystery. A team of astronomers has gathered the largest sample yet of these little red dots, and their findings suggest that these ancient galaxies may not be breaking the laws of physics after all. Instead, something even more dramatic may be happening inside them. It turns out that the vast majority of these little red dots, galaxies that existed earlier than 1.5 billion years after the Big Bang, appear to host rapidly feeding or accreting supermassive black holes. And this might just be the key to solving the puzzle. Because if true, it would mean that much of the intense light coming from these galaxies isn't starlight at all. It's the chaotic, high-energy radiation produced by matter spiraling into a black hole. Let's break it down. The problem began when JWST first discovered these little red dots. Their brightness didn't match their age. If all that light came from stars, it would suggest they had already formed huge stellar populations, and that simply didn't make sense according to standard models of cosmology. In other words, it looked like JWST had broken the universe. But now, astronomers think they've found a more plausible explanation. The research team behind this discovery analyzed the largest collection of these objects to date, using JWST data from multiple deep sky surveys. Sears, Jades, NG Deep, and perhaps most crucially, RUBY's, short for Red and Owns, Bright Infrared Extragalactic Survey. Thanks to these projects, scientists were able to study a large sample of little red dot galaxies. And here's where it gets exciting. They found that about 70% of these galaxies showed signs of extremely fast-moving gas, traveling at speeds of about 2 million miles per hour, or roughly 1,000 kilometers per second. That's not just fast, that's black hole fast. These turbulent gas motions suggest the presence of an accretion disk, a flattened spiral of gas and dust rapidly swirling into a supermassive black hole. This process releases enormous amounts of energy, creating what astronomers call an active galactic nucleus, or AGN. So when we see the little red dots glowing intensely in infrared light, we may not be seeing just stars, we may be seeing the dramatic feeding frenzy of a black hole in the early universe. That would explain their brightness, and crucially, it would bring our cosmological models back in line. The number of stars in these galaxies doesn't have to be absurdly high anymore. A bright AGN alone could account for the glow. As Dale Kachevsky of Colby College, the team's lead researcher, put it, "We're confounded by this new population of objects that the JWST has found. We don't see analogs of them at lower redshifts, which is why we haven't seen them prior to the JWST. In other words, they're unlike anything we've seen closer to home. These galaxies are unique to the early universe, and their light, stretched and reddened by billions of years of cosmic expansion, is only now reaching us." Let's talk about that red color for a second. The term redshift describes what happens when light travels across the expanding universe. As it moves, space itself stretches, and so does the light's wavelength. Shorter wavelengths, like blue light, get stretched into longer ones, like red and infrared. The farther a galaxy is, the more its light is redshifted. That's why JWST, which is designed to observe in the infrared, is the perfect tool for discovering these ancient galaxies. It can see what other telescopes simply can't, the deep, red, shifted light from galaxies that formed when the universe was still in its infancy. Team member Stephen Finkelstein of the University of Texas at Austin explained why this redshift distribution is so exciting. These really red, high redshift sources basically stop existing at a certain point after the Big Bang. If they are growing black holes, and we think at least 70% of them are, This hints at an era of obscured black hole growth in the early universe. That era of obscured black hole growth is a fascinating idea. It suggests that in the early universe, many galaxies may have gone through a phase where their central black holes were rapidly feeding, but hidden behind thick clouds of gas and dust. The resulting energy lit up the universe in infrared, but not in X-rays or visible light. Which brings us to another important clue. Most AGNs in the local universe, like the ones near the Milky Way, are bright in X-rays. That's because the regions around black holes get incredibly hot, emitting powerful X-ray radiation. But the little red dots from JWST don't show strong X-ray signals. Why not? The answer might be obscuration. If these galaxies are shrouded in dense gas and dust, those materials could be absorbing the X-rays. That would explain why these black holes appear dim in high-energy light while still glowing brightly in infrared. The black holes are there, they're just buried. So if that's true, what happens to these galaxies over time? One possibility is the inside-out growth model. In this view, star formation starts in the dense central regions of galaxies and then spreads outward over time. As that process unfolds, supernova explosions and stellar winds push gas away from the center, thinning the cocoon around the black hole. Eventually, the AGN becomes less obscured. The galaxy stops looking like a little red dot and starts shining in bluer wavelengths, maybe even resembling galaxies we see closer to the present day. Anthony Taylor of the University of Texas at Austin summed it up well. This is how you solve the universe-breaking problem. It's not that early galaxies were impossibly massive. It's that we misunderstood where the light was coming from. The intense brightness didn't necessarily come from huge numbers of stars, it came from black holes growing rapidly in the dark, dusty hearts of baby galaxies. But that doesn't mean all the questions are answered. One of the biggest mysteries that remains is this. If these little red dot galaxies were once so common, where did they all go? Why don't we see lower redshift versions of these galaxies in the nearby universe? Again, the inside-out growth theory could help explain this. Over billions of years, galaxies evolve, clear out their dusty centers, and transform into very different-looking structures. But it's still an open question, and researchers aren't done exploring it. As Kachevsky said, there are always two or more potential ways to explain the confounding properties of little red dots. It's a continuous exchange between models and observations, finding a balance between what aligns well between the two and what conflicts. So what's next? The team plans to study these galaxies in even more detail, especially in mid-infrared light, to get a better sense of what's happening inside them. They're also looking at other types of light, other wavelengths, and making plans for deeper follow-up observations. Every bit of data helps sharpen the picture. Because the truth is, we're still learning how the first galaxies came to be. And thanks to the James Webb Space Telescope and the mysterious little red dots it uncovered, we may finally be unlocking the secrets of the cosmic dawn. JWST didn't break cosmology. It might have just saved it. And that's it. Thanks for watching Spaceverse. What once looked like a universe-breaking mystery now points to a hidden era of ravenous black holes shaping the cosmos. The little red dots may not be breaking the rules, they might just be revealing new ones. Subscribe for more journeys through deep space, cosmic puzzles, and the secrets the universe is only beginning to share.